in shift 2 1st February 2023. So if you look here, what we want here is that find the number of integral values of k for which one root of this equation lies in the interval 1 2 and the other root lies in the interval 2 3. So this is a very simple question. So you have to see what exactly they are asking us to do. So if I draw this thing, if I try to do this, so I have this interval 1 2 2 3, and if you look at your equation, so the equation is quadratic. So now because the equation is quadratic, so there are only two roots for this equation. Okay, so one of the root we want it to be in this interval and the other should be in this interval, right? So you see, what are the possibilities? Possibilities is that your graph looks like this. This is the one possibility, because this is the only way you can have two roots, right? And because this is actually a quadratic equation, so it will be like this only, right? So the graph is either like this, or let me draw like this. Okay, let me make another picture. So I have 1 2 here and 3 here, so it can be something like this. Okay, so in that case, what will happen? This and this will be my root. So if we find the value at 1, f of 1, you just put 1 is equal, x is equal to 1 here. So you'll see 2 into 1 square minus 8 into 1 plus k. So that is going to give me a k minus 2. Okay, and then if we compute the value f of 2, so that is going to give you 2 into 2 square minus 8 into 2 plus k. So that gives you 8 minus 16 plus k. So that gives you a k minus 8, right? So let us just, so this is k minus 6, because 2 minus 8 is 6, right? So this will be k minus 6. And in this case, if you compute f of 3, so that will be 2 into 3 square minus 8 into 3 plus k. So that is equal to, if you compute it, this is 3 square is 9 into 2 is 18 minus 24 plus k. So that is k minus 6, right? Now in this situation, if you look at situation 1, you want f of 1 to be positive. Okay, and now you see f of 1 is k minus 6 and f of 3 is also k minus 6. Okay, so we want f of 1 to be positive, f of 3 to be positive. So that gives us k minus 6 to be positive. So that gives us k should be greater than 6. And also we want f of 2 to be negative. So that gives you k minus 8 less than 0, and that gives you k less than 8. So you are looking for k greater than 6 and less than 8. So in that case, you get k is equal to 7. So there is only one solution, right? So there are options also. So one of the option was, let me write down the options also. The options are 0, 1, 2 and 3. So this is option A, option B, option C, option D, right? Okay, and if you look at the second case, here you want f of 1 to be negative. Can you see? Because f of 1 is here. So you want this to be negative, and you want f of 3 to be negative, and you want f of 2 to be positive. If I want it to be negative, it means that I want k minus 6 to be negative. So that gives me k minus less than 6. And f 2 to be positive, that means I want k minus 8 greater than 0. So that gives me k greater than 8. So in this case, I am looking for k less than 6 and k greater than 8. That's not possible. So the only answer is that my k has to be equal to 7. So how many integral values of k? Only one. So your answer is, the answer is choice B. Thank you.